Assalamualaikum, Bismillahirrahmanirrahim. Welcome to lecture number 26. In the previous lecture, we have studied some factors that affect the HVAC system, especially humidification and dehumidification, and psychrometric chart. On the bottom side we have a dry bulb temperature. The slant side we have a wet bulb temperature. By these two different values we can find out the relative humidity, and how can we reduce the humidity in the air. We learned it in this way. Anyway, I just found very animated video of desiccant wheel dehumidification done by two process. One of them is by desiccant wheel, and then desiccant wheel we have a silica gel material that absorb the moist air or absorb water present in the air. And just like in this picture, the air is coming over here and it become dry, but uh, the amount of desiccant wheel is consumed. It need to be regenerated. It can hold, let's suppose, 0.15 milligram of water, but after that it cannot absorb more water, so it can regenerate by reactive hot air. By hot air, the moisture present in the silica gel that absorbed in the silica gel evaporated and goes out to the outside air. Similarly, second method, we cool down the air. This is the basically schematic of air handling unit. This is the cooling coil. The cooling coil could be refrigerated one or chill water one. We already learned the chill water circuit too, chill water chiller too. So in the chiller, the cooling coil, air cools down to the dew point, and after reaching the dew point it expelled the water, and that's why from the indoor unit you can see the water running out from the indoor unit. So it can collect in this trays and then went out from this air handling unit, and then it reheat to a certain point where which you need to have a particular particular dehumidified air, just like in pharmaceutical companies. Okay, but normally heating coil is not used in our system. When the air react with surrounding air, it gets heated to normal temperature, and thus the process goes on like this way. This is basically the real picture of cooling coil. The air pass out from this point, this is the blower, and water is collected in the bottom tray. So now we have learned this video too. Let's study uh, the basic machinery behind the HVAC system one by one. The first system that directly related to us is air side system. The cooling of the air. The cooling of the air is done by air handling unit. As you learned in previous video, air handling unit just cool down the air and send it to the room or any office or any room which need to be air conditioned. Okay, now how the air is cooling, either by chill water, the refrigeration cooling the chill water, and then chill water cool the air, and the rooftop unit or package unit direct refrigerated cooling coils cool down the air side, just like your indoor unit or your room AC. But in commercial and office building, we have a very large refrigeration circuit. Like I was in English Biscuit Private Limited, we have 1,000 ton of chilling. So we have a 500 ton chiller, 300 chiller, and 200 chiller. All that chiller cool downs the chill water, produce the chill water, and then chill water is distributed in many offices and many blocks of the buildings, like powerhouse, like production house, like mixing house, so on. And similarly, the refrigeration circuit also need to be reject heat. The rejection of heat done by the condenser, just like outdoor unit. If it is a rooftop unit or package unit, it directly reject on outside air. But in the chiller, basically it is not done by the only air. It first reject heat in water, that heat rejection circuit, and that water is goes to the cooling tower, and cooling tower reduce the temperature of the water. Now comes to the air side loop. You can see from the in any building, office or malls, you see that some kind of diffusers in the building. That we have two blocks. First one is the supplier, which supply air from the air handling unit to the room, and one one vacant space return the air from the room. So we have incoming air and also hot outgoing air. The cooled air comes in the room, dehumidified air. Now in the room we have two type of heating: sensible heating and latent heating. You already discussed in thermodynamics. So the person particular in the room produce two type of heating. It producing moisture due to the its own sweat, जिसको हम पसीना बोलते हैं, उस sweat की वजह से due to the sweat the water evaporate in the air. So the air becomes very humid. You see that especially in the masjid, when the lots of people filled up in a single space, we have a suffocation problem due to this humid produced by the person. And second one is temperature. The person temperature is around 37, so it was also hitting the surrounding air. So that cool down, supply air cool down the person, and also let's suppose the air is coming have a relative humidity 40-50%, but when it's react with surrounding air it becomes 70%, but still person feel comfortable effect because it mixes with the surrounding air, but still the surrounding temperature becomes to the desirable level, like 23 degrees centigrade. So the supply air coming from the air handling unit could be of 16 degrees centigrade, but when it mixes with the surrounding air, the surrounding air becomes 23, so person becomes feel comfortable effect, and when it's heated it's returned from the return ducts. So this is air side loop. The first two comfort requirement mentioned temperature and humidity. Okay, now the cooling load. What could be the cooling loads in the room? This picture well represent the cooling. Cooling load should be required to level up the heating space. Like lot of things is heating the room, like we have lights is also producing heat, the PC, there's a window, the glass window, the sunlight coming inside the room and heating the room, and lots of things which is producing heat. So to overcome that heat, we need to done by the cooling load. Like the 1000 ton of chiller means it is producing 1000 ton of chilling that compelled with this heating space. So this is cooling load requirement. Now the air handling unit, which is directly related to the air side of loop. This is basically picture of air handling unit. The first one is the blower that suck the air and supply to the room. Okay, this is return air. This is return air grill, like this. The return air comes from the grill to this point, and due to the blower it is sucking the air. So first it mix with the outdoor air. You know, we just learned that we need to have a ventilation, and as per ASHRAE law the ventilation should be 30 liter per second per person. So you can calculate the how many person, the average person living in the room or present in the room. So you can calculate the amount of fresh air needed to mix with the return air. We cannot completely take return outdoor air, because outdoor unit have a high temperature, high humidity, also it has very dusty, because outside we have a dust and pollens and etc. So that's why you can see from this picture we have two types of filter. The first pre-filter clean the outdoor unit from the dust particle, pollen particles. Now it mixes here. This is basically a mixing section. It mixes with return air, and then again we have a filter. Okay, and this is a very fine filters. In the next slide we discuss about the filters too. Then it goes to the, this is cooling coil. This is cooling coil. Then it goes to the cooling coil. Whether its cooling coil is directly cooled, the air is directly cooled by refrigerant or by the chilled water. Both possibility can be done in air handling unit. It then it goes to the reheat coil. You see that in many very particular areas like pharmaceutical companies, where we have very accurate value of humidity, so we need to put some reheat coil to again reheat the air and uh, makes it a requirement humid level. Okay, now then the blower is supplying the air to the room. So this is the basic construction of air handling unit. And if it is a if this air handling unit consists of second type of dehumidification process like desiccant wheel, so on that case we don't have a reheat coil but the desiccant wheel over here that removes the humidity from the incoming air. Okay, the person also producing humidity and outside air also have a humidity, so from both these two kind of process remove the humidity from the incoming air. And we also, in some very minute areas where we have a very dry weather, we need to make humid environment. So on that case we have some water water tank over here and some heating strip which boils the water and producing steam. So steam mixed with the incoming air, so the air becomes humid, but it is not very available in the market, and it's used in very minute or very dry air. In I don't see in any in Pakistan any air handling which comprises of the humidifying effect. Okay, mostly we need to do dehumidification. Okay, now from the next picture, this is basically schematic of air side loop. This is room. The blower is supply air from first it taking clean the outside air from preheat, then from the back filters. This is basically back, this is pre-filters which cleans the outside air. This is fine filter, back filter. Okay, then this air goes to the cooling coil, then the blower is pushing the air towards the room, and then we have a return air, so the return air comes over here, and some of the air also exhausts and like if we take air outside air around 30%, so 30% of this room also need to exhaust. Then we have a very special type of HEPA filters. It is used in manufacturing facilities like pharmaceutical company. It is placed in the supply after the blower, because it has very fine space, and from the space only it cleans almost all the dust and pollen particle. That's why the standard written on the HEPA filter is 99.99% clean air particles. So that's why it is placed on the out supply air line. Okay, now for the air side we have two kinds of controlling system. Like if we maintain the room temperature around 23 degrees centigrade, then we can have two kind of control loops. Okay, one is constant air volume system, and another one is variable air volume system. The constant air in the constant air volume system, it just resemblance with your indoor unit, because indoor unit, the blower inside the indoor unit, it has fixed flow. You have an option to increase the fan speed, but the fan speed will not changing with respect to temperature difference. So the constant amount of air is flowing in the room or coming into the room. The blower have a constant speed and it is flowing the constant air inside the room. So how the temperature maintain? If the temperature in this room, the continuously cool air is coming over here and it cools down the air. First the room temperature is 30 and then is cooled down to 23 degrees centigrade, that is desirable temperature. So after reaching that 23 degrees centigrade, it basically cut off the cooling coil. If it is a refrigerant base, it directly shut down the compressor. If it is a chilled water base, we have a valve in the cooling coil which close the chilled water line. So when there will be no chill water, it will not further cool down the air. So that's in this way the room temperature is maintained. But we do not shut off this blower, because in closed environment you see that we don't have any fans. We also need to maintain the uh, air movement that we already studied. It is studied in the previous slides, where the person should also have a air movement to have a comfortable effect. Okay. Similarly, in the indoor unit, when the in split AC reaches the its is set point, the blower do not shut off, but the compressor behind the outdoor unit, it stop. So it just recirculate the air but not cool down the air. Okay. This is the schematic of constant air volume. This is a thermostat that gives direction, that gives signal towards the uh, wall or directly to the compressor. Second system, we have a variable area volume system. Okay. In variable area volume system, we have a VAV like this. You see that it is directly attached with the motor, and the disc is run with the motorized effect. The motor open this valve or close the valve or adjust the flow, not completely shut off the air, because you see that we also need to maintain some ventilation. Okay. Okay. So when it's work on the proportionality limits. When the temperature in the inside the room it's closes to 23, like 24, 25, so it's close down the damper to the certain level, so less amount of air can be enter in the room. So less chilled water enter into the room, so less will be the temperature difference will occur. Okay. So it works on that principle. VAV system. This is basically air distribution system. This is air handling unit, which we already studied in the previous drawing schematics. This is a return air inlet from the inside the room. This is the outdoor unit that mixes in the mixing box. Then it goes to the cooling coil. The filter. Then it goes to the cooling coil. Then it goes to the, if it is a very accurate system of humidity, it goes to the desiccant wheel or reheat coil. But normally in Pakistan, we but normally in Pakistan we don't have um, mm, desiccant wheel or reheat coil in many normally used building of like malls, like supermarkets. But in pharmaceuticals, where we have a particular standard of humidity, we need to place desiccant wheel or reheat coil and send the accurate amount of humidified and temperatured air. Yes. So this is the basically background circuit of ear side. This is ear side circuit. But you see that in the malls, you cannot see that circuit because it is hiding in the ceiling and the roof. and in between the area it is called planning. So in this roof and the ceiling portion, this air side circuit, the supply air ducts, the branches of supply air ducts, and similarly in this way we also have a return air ducts. Just like you can see in this picture, we have a return air, we have a supply air, we have a supply air ceiling, and we have a return air ceiling. So but you can see that kind of a circuit in supermarkets. Like if you go to the metro supermarket, you can see that on the top of the roof, it is the whole branches of supply ducts and these ceilings you can see on that place. Even though when we have a regular class, like we have previous batches, I just just arrange the class in the lab, in mechanical engineering lab, where we all have that kind of a supply air duct, returns duct, air handling unit available in the lab, so student can physically see these type of machine, and it is very interesting. But now it's a very difficult even for me to make you understand about that physical machines, but still I'm trying my best, okay, by animation and videos. So basically it is a air side loop, and the air side loop is cooled down by either chill water circuit or either refrigeration circuit. If it is a rooftop unit or your home window AC or your split AC, the air side loop is cooled down by refrigerant. But in industries, in commercial offices, we have lot of rooms to be cooled down, lot of blocks to be cooled down, and we have one single chiller. So we distribute that cooling through chill water, okay, through chill water. We first chill the water by refrigeration circuit, and that chill water is transferring to this cooling coil through pump, okay, like this. This is a complete circuit. This evaporator coil is cooled down by the refrigerant, and this chill water circulate through pump. So the refrigerant cools down the water to the 5.6 degrees centigrade, and when it goes to the cooling coil, it cools the air, and itself it's gain the heat. So in this, the incoming portion is also water, the outgoing is also water. So it is what? It increasing its own temperature, not changing its phase. Whereas in the refrigerant loop, the refrigerant itself do not reduce or increase the temperature itself, but it changed its phase. Like the coming refrigerant is in the liquid form, but outgoing refrigerant is in the gases form. Similarly, this kind of shell and tube heat exchanger is used to cool down the water from refrigerant. From the shell side, in the shell side we have a refrigerant, and the refrigerant cool down this. You can see that it is a long copper tube. There is a lot of tube connected here. So water coming in the copper tube, and the surrounding surface or space is filled by the refrigerant. So refrigerant basically cools down the water and do not collide itself. It just transfers the heat. It itself changes its phase from liquid refrigerant to gas, and that gas goes to the compressor, and the circuit is going. You already learned the refrigerant circuit, and the water coming from cooling coil, it's gain temperature around 13 to 15 degrees centigrade. So when it collide with the chilled refrigerant, it cool down to 4 to 5 or maximum 7 degrees centigrade. So this is basically chill water circuit. It is the flowing of liquid is done by pump, and the flowing of refrigerant is done by the compressor. You already learned the compressor circuit. So basically this is the small chill water circuit. You may ask the question that if the room temperature comes to the set point like 23 degrees centigrade in your home indoor split AC, the compressor shut off and the blower, but still the blower is running. So when we have this kind of a chiller system or chill system, when the one rooms get the set point temperature and another one is not. So this is basically the schematic of, we have a two air handling unit. One air is going to certain room and one air is going to the certain room. One room get set temperature and another one did not. So if we have a control air volume system that we already learned in CAV, when the room temperature gets normal, it have the thermostat and the room temperature gets to set point, this valve shut the chill water coming into the cooling coil. So the chill water will not come in the cooling coil, so air in flowing from cooling coil will not get cools down. But if we shut off this valve, the pump is continuously running because the second circuit should also need to run. So we have a bypass line by which if we shut down this valve, the water will not come from the cooling coil, but it bypasses and goes like this, and that circulate in this way, then cools down from the evaporator of the refrigeration heat exchanger and then goes to if one room temperature has gained a set point, this valve shut off, another one is not, so it continuously ringing from the control valve. In this way the controlling circuit also run. We will discuss it in a detail in later when we come to the controlling circuit. It is just a normal schematic how we are controlling the temperature of two or multiple rooms. Okay, so this is the complete circuit, not a complete circuit till the refrigeration loop. So you can see that this is the compressor. In the previous animation you see that the liquid refrigerant comes and it changes from liquid to gaseous phase. So here we have liquid refrigerant coming very chilled 3.3 degrees centigrade and goes toward the compressor and becomes a gas in the gas form and goes toward the compressor, and compressor compress the gas and goes to the condenser. Then it's cooled down the temperature like 48.9 degrees centigrade to 43 degrees centigrade, and by the expansion valve or capillary tube this 43 degrees centigrade cools down to 3.3 degrees centigrade, and then the refrigeration circuit goes on. Similarly, it cools down the water from 13 degrees centigrade to 5.6 degrees centigrade. This circuit is visible. So refrigerant basically cools down the chill water, and the chill water cools down the air, and the air cool down the surrounding room, persons, and whatever heating equipment is producing. So it cools down that equipment. So now one last loop is left, that is a condenser loop. Yes, if we have simple air cooled chiller, the heat is rejecting directly from refrigerant to air from heat exchanger. As you seen in the outdoor, in the tube we have a refrigerant and the air is passing from the fins and reject heat from the refrigerant gas, and the gas changes its phase from gases to liquid, like in this way. But if it is a like in no chill water loop or air cooled chiller, this is basically the circuit. The air cools down from condenser and air is rejecting heat from the refrigerant gas. Now if it is a chill water chiller, you already learned that chill water chiller, we do not reject the heat directly into the air. We first absorb the heat into the water just by putting pump. The pump flows the liquid from the cooling tower sump to the condenser, just like this way. Similarly, you can imagine this in opposite direction. Basically this loop, but you can imagine it in opposite direction, that like hot water, the cold water coming over here, over here and cools down the refrigerant and the gaseous refrigerant coming over here, and it changes its form from liquid from gases to liquid and goes towards the again expansion valve, and the water absorbs the heat from the condenser and goes toward the cooling tower, and through cooling tower the water rejects heat to the atmospheric air. So in the cooling tower system we have two advantage. In air cooled chiller, the heat is directly rejected into the environment air. If the environment air temperature is like 40 35, so we need very high blowers that need to reject heat from the condenser. But in cooling tower circuit we absorb the heat and reject the heat in the environment in two ways. One is through, this is basically this is basically picture of cooling commercial cooling tower utilized in the buildings. You can see that type of cooling tower in Millennium malls and different offices building where we have a central air conditioning system. So basically water water coming from absorbing heat from the condenser come over here and is spray the water in the shower the water here, and from the bottom the air is passing, and we have a fan over here that circulating air. So the air contacting with the hot water also reject heat, like temperature of a condenser water is like 60 or 65 degrees centigrade, and outside air temperature is 35. So it is rejecting heat in this way. And the second way is evaporation process. Through evaporation some amount of water attach with air and take away with air, so the remaining water left gets cooled down. So in the cooling tower we also have a makeup line, because some of the air rejecting in the atmospheric air. So the amount of air reject from the condenser water is adjusted with the makeup water, but due to this evaporation lot of heat is reject from the condenser water. Like evaporation process, if you spill over the water in the floor, when the water evaporated you feel that the floor gets cooled down. So basically air is rejecting water, air is absorbing water, so the amount of energy is released, so due to which evaporation process you can feel the cooling effect. Simple like deodorant spray, when you spill the deodorant spray liquid spill over your body and it rejects heat from your body and itself evaporated. So we have advantage of cooling tower that it rejects the heat in two ways. One, directly by coinciding with the incoming air that have a lower temperature, another way of evaporation. So cooling tower system have a better efficiency as compared to air cooled chiller, but it also depends upon the area. If your site is situated near to the sea level, just like in Karachi we already have a very high humidity, so the cooling tower will not perform very well, because it will not evaporate much water and will not reject much heat. But it is placed like in Quetta or very dry places, so it will work very well. Very single in a very short time lot of heat is released from the condenser water. Okay, this is basically animation and video of cooling tower. You can its voice.
The key components of a cooling system are the cooling tower, recirculating pump, and heat exchanger. Cooled water from the basin is pumped through a heat exchanger. The cooling water picks up heat and its temperature increases.
The refrigerant gets
warm water is distributed over the top of the tower, where air moves past the warm water, evaporating a portion of the water,
like you see
cooling the remaining water, repeating the loop. Cooled water from the basin is pumped through a heat exchanger and so
heat from the water and also evaporates some water.
As the basin water level drops,
due to which water will
Fresh
evaporate.
makeup water is
We
added.
need to make some makeup water.
Evaporated water leaves behind dissolved impurities from the makeup water, which concentrate and cause scale, deposits, and corrosion. Concentrated impurities in the tower are removed, blowing down tower water to the drain.
This is basically main function of the cooling tower that explained in this video and animation. You see that the water is absorbing heat from the condenser, like from this pump, and goes to the top of the cooling tower. It sprays the water, and from the bottom the air is passing. So how much the air is coincide with the water, it takes heat from hot water. Also some amount of water evaporate, and we have a blower, so that have a continuous flow of air. So in this way, the water cools down, like it when the incoming water from the condenser is 58 or 50 degrees centigrade, and from this cooling tower, it temperature cools down to 23 degrees centigrade. So you can see that when the 23 degrees centigrade meet with the condenser of 58 degrees centigrade, it suddenly cools down the refrigerant. So in this way, the cooling tower circuit have very high efficiency if it is a place on dry places. But even though if it is situated in Karachi, that have a humidity around 70 to 80, but still 30% of air have a ability to absorb water. So even on that places, it rejects heat for from evaporation process too. So in this way, refrigerant cools down very effectively. That's why the if the lower temperature if if the lower refrigerant cools down suddenly, so less amount of energy needed uh, for the compressor. Like the the compressor will stop very quickly. If it is a air cooled chiller system, the condenser is cooling by the 35 or 40 degrees centigrade of surrounding air, but from cooling tower it is cooled down by 20 to 23 degrees centigrade. So you can imagine that refrigerants gets cooled down very quickly. So compressor don't need to run for a very long time. Like if we have a air cooled chiller, it runs uh, to maintain room temperature like 2 hours. Like for five, if we have a 5 year working in a room, the compressor runs only 2 hours, only runs 3 hours. In 3 hours is maintaining the temperature. But if we place cooling tower in that circuit, it's cooled down even in the lower time. Like in air cooled chiller circuit, the compressor is running for 3 hours, but if we place cooling tower circuit, it runs like 2 hours. So in this way, cooling tower circuits have a high COP, coefficient of performance. You already learned the efficiency of a refrigeration circuit, performance of a refrigeration circuit expressed in the COP. So chilled water circuit have a high COP, and the air cooled chiller has a lower COP. That's why in industries we are making cooling, we are producing air conditioning in very low amount, like 70 to 8 rupees per ton of uh, cooling here. Whereas in your normal air cooled circuit like a split AC, uh, the the unit becomes 22-25 rupees per ton of chilling. I physically personally calculated in one of my FIP project. So till then, I hope it's very informative video and lecture. In the next lecture, we will do some numerical, and also I like to uh, express some physical system and explain. Or we already learned the theoretical schematic drawings, but now in the next lecture, I'll try to make do some one numerical related to HVAC. And in HVAC we only have one numerical, and I also try to I cannot arrange the physical class to the mechanical engineering lab where you can see all the system physically, but still I try to place some informative video in which the physical system has been shown. Okay, till then, Khudafis, take care.